Good morning, students. Today our topic is exercise 8.4 fifth sum. Find the area of the parallelogram whose two adjacent sides determined by the vectors. Let first one is A vector, second one is B vector. Okay, now listen to the concept. Find the area of the parallelogram whose two adjacent sides are given by the vectors A vector and B vector. Let A vector equal to first one, B vector equal to second one. And here, parallelogram, that is important. What is a given parallelogram? Listen, given that parallelogram, area of the parallelogram. Listen, area of the parallelogram whose two adjacent sides given. Let A vector is equal to one adjacent side, and that is first one is A vector and the second one is B vector. Okay. Now can you tell me what is area of the parallelogram with adjacent sides A vector and B vector is given by the formula? Very good. Modulus A vector cross B vector. That is, area of the parallelogram with adjacent sides A vector and B vector is given by the formula modulus A vector cross B vector. That is, area of the parallelogram is equal to, that is, modulus cross product of these two vectors. That's all. So area of the parallelogram with adjacent sides A vector and B vector is equal to modulus A vector cross B vector. That's all. Okay. Now what is the steps? Working rule. Step 1. Very good. Step 1 A cross B. Step 1 A cross B. Next step 2 modulus A cross B. Step 3 formula. That is, area of the parallelogram with adjacent sides A vector and B vector is given by modulus A vector cross B vector. So step 1 A cross B. Step 2 modulus A cross B. Step 3 formula conclusion. That's all. Okay. Now let A vector equal to first one, B vector equal to second one. Listen carefully. Let A vector is equal to, let A vector is equal to I cap plus 2j cap plus 3k cap. Okay. Let B vector is equal to, let B vector is equal to 3i cap, next minus 2j cap plus k cap. That's all. Okay, let A vector, B vector ready. Now I want to find, very good, A vector cross B vector. Now listen, A vector cross B vector is equal to determinant. Listen, if the cross product is defined between the two vectors, its result is given by determinant ijk. Okay, determinant ijk. Determinant ijk. Okay, determinant ijk. Now, here first A vector, therefore A vector coefficients, very good, second row. So A vector coefficients right in second row. That is, what is A vector? 1, 2, 3, A vector. A vector coefficients 1, 2, 3. Okay, now next, second B vector. B vector coefficients in third row. Okay, what is third row? Is B vector 3 minus 2, 1. 3 minus 2, 1. Okay, 3 minus 2, 1. Now as usual, plus, minus, plus, which is equal to I cap into. Now yourself. Good. Forget. It's respective row and column. Okay, cross multiply. Very good. 2 into 1, 2. And in this direction, always 1 minus. So 2 plus 6. Good. 2 plus 6. Minus into j. Minus j cap. Okay, into. Now forget. It's respective row and column. Okay, can you tell me answer? Very good. 1 minus 9. Cross multiply. 1 minus 9. Yes. Plus into k. K cap plus k cap into. Forget. It's respective row and column. Cross multiply. Good. Minus 2. Yes, minus 6. Minus 2, minus 6. Okay, which is equal to, what is first one bracket? 8, very good. 8 into I cap, that is 8 I cap. Okay, second bracket, yes, minus 8, minus into minus, plus. So, plus 8 j cap. Okay, last bracket, good, minus 8. Minus 8 into plus, minus, that is minus 8 k cap, which is A vector cross B vector. So, A vector cross B vector ready. Okay, now let us write a directly formula, because area of the parallelogram with the adjacent sides A vector and B vector is given by the formula modulus A vector cross B vector. Okay, A vector cross B vector ready, write formula and work out yourself. Listen, area of the parallelogram. Area of the parallelogram. Area of the parallelogram with adjacent sides A vector and B vector. With adjacent sides. With adjacent sides A vector and B vector is given by the formula. Okay, can you tell me the formula? Good. Modulus A vector cross B vector. Okay, that's all, which is equal to. Yes, A vector cross B vector is known. We need modulus. Modulus means, yes, magnitude. Okay, magnitude of A cross B is equal to, yes, square root of sum of the squares of ijk coefficients. That is I coefficient 8. So 8 the whole square. Plus of j coefficient 8 the whole square. Plus of k coefficient minus 8. So minus 8 the whole square. Okay, which is equal to square root of yourself. Very good. 8 square equal to 64. Plus 8 square equal to 64. Plus minus the whole square equal to positive. Good. Because, yes, square gives always positive. So plus 64. Extend to the root. Now, which is equal to? Okay, suppose, which is equal to? Which is equal to, say, square root of 64 plus 64 plus 64. Simplification yourself. Very good, very, very good. It is of the form x plus x plus x equal to 3x, which means 3 times of 64. So, which is equal to square root of 3 times of 64. Okay, which is equal to square root of 64 equal to, yes, 8. And 3 arrests in root itself, so 8 root 3. Okay, now I want to write question with answer. Therefore, area of the parallelogram with the adjacent sides A vector and B vector is equal to 8 root 3 square units. Therefore, area of the parallelogram. Listen, therefore, area of the parallelogram. Area of the parallelogram with adjacent sides. With the adjacent sides A vector and B vector is given by the answer. What is answer final? Good. 8 root 3 is equal to 8 root 3 square units. Okay. Area of the parallelogram completed. Listen, suppose same question, but the keyword only differs. Listen, find the area of the triangle. Suppose the question, same numbers, but this keyword only differs. Find the area of the triangle whose 2 of the adjacent sides A vector and B vector is given by the formula. Very good. Just half into modulus A cross B. Parallelogram area means modulus A cross B. Area of the triangle means half into modulus A vector cross B vector. So that is a difference. Can you tell me what is the difference between area of the parallelogram and the area of the triangle? Good. Area of the parallelogram means modulus A vector cross B vector. Area of the triangle means very first half, that's all. Because a parallelogram contains 2 equal triangles. A parallelogram contains 2 equal triangles. Listen, downwards one triangle and upwards one triangle, and these 2 triangles are equal in area. Therefore, area of the triangle means half into modulus A vector cross B vector. Same working rule. Children, listen. Now, 6th question from exercise 8.4. Find the area of the triangle. Find the area of the triangle. whose vertices are A is a point of, B is a point of, C is a point of. Before question, find the area of the parallelogram. Now, area of the triangle. Sir, okay. Here, before question, adjacent sides given. But now, yes, vertices given. That is the difference. Okay, here keyword is a triangle and the vertices of the triangle given. First, let us draw the diagram. Listen. So, listen. First, let us draw the diagram. Listen carefully. Let us draw the diagram. Triangle. So, draw the triangle. Let A, B, C be the given triangle. Can tell me A is a point of? Yes, A is a point of 3, minus 1, 2. A is a point of 3, minus 1, 2. Next, B is a point of? Yes, B is a point of 1, minus 1, minus 3. 1, minus 1, minus 3. C is a point of? C is a point of 4, minus 3, 1. Okay, that's all. Now listen again. Find the area of the triangle ABC whose vertices are A is a point of, B is a point of, C is a point of. Find the area of the triangle whose vertices given. Suppose adjacent sides given means area of the triangle is equal to half into modulus cross product of adjacent sides. But now vertices given. So vertices given. So first we want to find adjacent sides. Okay. Here in this diagram, can tell me the two adjacent sides? Yes. That is AB vector and the AC vector. AB vector and the AC vector are the adjacent sides. Okay. Now in this diagram, area of the triangle ABC is equal to half modulus AB vector cross AC vector. That's all. So first I want to find the AB vector. Can you tell me what is AB vector? Yes, second minus first. AB vector is equal to OB vector minus OA vector. Okay, next I want to find the AC vector. AC vector equal to? Good. OC vector minus OA vector. That is second minus first. That's idea. Listen, which is OA vector. Okay, OA vector equal to, it is OB vector is equal to, it is OC vector is equal to, where OB the origin. Origin is anywhere. Okay. The position vector of A with respect to origin O is OA vector. So OA vector equal to 3i cap minus j cap plus 2k cap. Similarly yourself? Yes. OB vector is equal to the position vector of B with respect to origin O is OB vector equal to I cap, yes, minus j cap minus 3k cap. Okay, very good. The position vector of C with respect to origin O is OC vector is equal to, anyone? Yes, 4i cap minus 3j cap plus k cap. That's all. Okay. Now, let OA vector equal to OB vector equal to OC vector equal to. So, which is the next step? Listen. Let OA vector. Let OA vector is equal to 3i cap. Okay. 3i cap minus j cap plus 2k cap. Next, OB vector. OB vector is equal to, yes, good, I cap minus j cap minus 3k cap. Next, OC vector is equal to, OC vector is equal to 4i cap minus 3j cap plus k cap. Okay. Now, I want to find AB vector and AC vector. Okay. Now, AB vector. Okay. AB vector equal to, yes, second minus first. That is OB vector minus OA vector, which is equal to. So, OB vector minus OA vector. Okay, what is OB vector? Yes, OB vector is equal to I cap minus j cap minus 3k cap minus OA vector. OA vector is equal to, yes, 3i cap minus j cap plus 2k cap. Now just a subtraction, okay, which is equal to, good, minus 3i cap, minus going to multiply all the elements. So minus 3i plus I, minus 3i plus I, which is equal to, yes, minus 2i cap, minus into minus plus j, here minus j. Listen, remember, plus j minus j cancel. So j cancel. J cancel means 0 j cap. Okay, plus 0 j cap. Okay, next, minus going to multiply inside. Minus 2k cap minus 3k cap, totally, yes, minus 5 k cap, which is AB vector. Okay, AB vector is ready. Next, I want to find AC vector. Okay, AC vector equal to, yes, second minus first. OC vector minus OA vector. Okay, which is equal to OC vector minus OA vector. What is OC vector? Yes, very good. OC vector is equal to 4i cap minus 3j cap plus k cap. Okay, minus OA vector. OA vector is equal to 3i cap minus j cap plus 2k cap. Okay, now simplification yourself. Minus going to multiply inside. Minus 3i plus 4i. So 4i minus 3i, which is equal to, yes, I plus I cap. Next, is it minus into minus plus j. Here minus 3j. So plus j minus 3j. What is your answer? Good. Minus 2j. Next, minus 2k. Minus going to multiply inside. Minus 2k plus k. So minus 2k plus k, which is equal to minus k. Okay, which is equal to minus k. It is AC vector. Remember again, find the area of the triangle whose vertices are given. Okay, vertices are given. Now area of the triangle ABC equal to half into modulus AB vector cross AC vector. Okay, that is half into modulus cross product of adjacent sides. Here AB vector and AC vector taken as adjacent sides. Okay, AB vector, AC vector ready. Now what is the step? Next step? Yes, very good. Now I want to find AB vector cross AC vector. AB vector cross AC vector. So which is the next step? Now listen. AB vector cross AC vector, which is equal to AB vector cross AC vector. Okay, now yourself. Good. If the cross product is defined between the two vectors, its result is given by, yes, determinant IJK. Determinant IJK. Okay, determinant IJK. Now, AB vector, first AB vector. AB vector coefficients? Yes, in second row. What is second row? AB vector. AB vector. Minus 2, 0, minus 5. Minus 2, 0, minus 5. Okay, minus 5. Next. AC vector. AC vector coefficients? Yes, in third row. Oh, what is third row? AC vector. AC vector 1, minus 2, minus 1. 1, minus 2, minus 1. As is well. Plus, minus, plus. Now here after reversal. Okay. Plus into I cap. I cap into. Yourself? Yes. Forget its respective one column. Cross multiply. 0, minus 10. 0 minus 10. Okay. Minus into j, minus j into. Minus j into. Forget. It's respective one column. Very good. 2 plus 5. 2 plus 5. Good. 2 plus 5. Next. Plus into k cap. So plus k cap into. Plus k cap into. Yes. Forget its respective one column. 4 minus 0. 4 minus 0. That's all. Okay, which is equal to, what is first bracket? Yes, minus 10. Minus 10 I cap. Minus 10 I cap. Yes, second one, very good. Minus 7 j cap. Minus 7 j cap. Okay, next last one. Yes, 4. 4 into k cap plus 4 k cap. The left hand side is AB vector cross AC vector. Okay, AB vector cross AC vector ready. Okay, AB vector cross AC vector. Now let us write directly formula. That is, area of the triangle ABC is equal to half modulus. Okay, area of the triangle ABC equal to half into modulus AB vector cross AC vector. Okay, modulus means what? Yes, magnitude. That is square root of. Okay, sum of the squares of IJK coefficients. Now next step is very simple. Area of the triangle. Area of the triangle ABC. Area of the triangle ABC is equal to half into modulus AB vector cross AC vector. That's all. Formula ready. Area of the triangle ABC equal to half into modulus AB vector cross AC vector. Okay. Now, half into, what is modulus AB vector cross AC vector? Yes, already AB vector cross AC vector is known. And modulus means what? Magnitude. Magnitude means, very good, square root of sum of the squares of algebraic coefficients. Okay, here minus 10 is square root of minus 10 the whole square plus of, yes, minus 7 the whole square plus of, good, 4 the whole square, extend. Okay, which is equal to half into square root of yourself. Good, very good, 100. Minus 10 the whole square equal to 100 plus of minus 7 the whole square. Good. Plus 49 plus of 4 the whole square equal to, yes, 60. Now, which is equal to half into square root of, just addition. Start. Yes, 6 plus 9, 15. Yes, 15 means 5. Remainder 1. So 1 plus 1, 2. 2 plus 4, 6. Yes, 6. Next, here 0. So 6 plus 0, 6. Okay, next, third digit. Yes, 1. That is 165. Therefore, area of the triangle ABC is equal to half into square root of 165, square root of 165 square units. 165, half into square root of 165 square units. Okay, square units. Right, it's the left hand side. The left hand side is area of the triangle. Area of the triangle ABC. Area of the triangle ABC is equal to half into square root of 165 square units. So which is the answer. Okay. Now for sixth question, area of the triangle ABC equal to half into square root of 165 square units. Suppose same question, area of the parallelogram means we need they are going to give you 4 vertices and draw the diagram, and area of the parallelogram is nothing but area of the parallelogram means half no name, that's all. Directly modulus cross product of adjacent sides for area of the parallelogram. Area of the triangle means half into, and the area of the parallelogram means no need of. Okay. Children listen. Now exercise 8.4, seventh sum. If A vector, B vector, C vector are position vectors of the vertices capital A, B, C of a triangle ABC, so that the area of the triangle ABC is half into modulus A vector cross B vector plus B vector cross C vector plus C vector cross A vector. So this answer we have to prove. That is, we want to prove area of the triangle ABC equal to half into modulus A vector cross B vector plus B vector cross C vector plus C vector cross A vector. Listen, this answer will be of the form cyclic order. That is, A to B, B to C, C to A, cyclic order. Okay? And there are how many terms inside the modulus? Very good. There are 3 terms are there. Listen, first term, second term, third term. Okay. And the middle relation is cross product, cross product, cross product. That is vector product. Okay, which is the first step. So that the area of the triangle ABC is equal to half into modulus A cross B plus B cross C plus C cross A. Next, listen. Second part. Also deduce the condition for collinearity of the points A, B and C. Is a question. Okay. See, there are 2 parts. Listen, which is the first part. So that the area of the triangle. And second part. That is, deduce the condition that the 3 points are collinear. That is, A, B, C are collinear means what is the condition, which is the second part. Okay. Now can you tell me, if area of the triangle equal to 0, then, very good. If area of the triangle equal to 0, then the 3 points are collinear. Conversely, if the 3 points are collinear, then the area of the triangle equal to 0. So which is the concept. So okay. So there are 2 parts. First part, second part. First part, here we want to prove area of the triangle. Second part, we want to find the condition for collinearity of the points A, B and C. Okay. Here, triangle is the keyword. Okay. Triangle ABC. Yes. Let the triangle ABC, listen. Let ABC be a triangle. Let ABC be a triangle. Let O be the origin. Listen. ABC be a triangle. Let O be the origin. Sir, okay. First part, so that the area of the triangle. Okay. Now can you tell me what is area of the triangle ABC equal to? Very good. Area of the triangle ABC equal to of into modulus AB vector cross AC vector, because here AB vector and AC vector are adjacent sides. That is, area of the triangle ABC is equal to of into modulus cross product of adjacent sides. That is, AB vector and AC vector, adjacent sides ready. Okay, now second part is very simple. Let the position vectors of the points A, B, C with respect to origin O are OA vector is equal to small a vector, OB vector is equal to small b vector, OC vector is equal to small c vector. Let the position vectors of A, B, C with respect to origin O are OA vector is equal to A vector, OB vector is equal to B vector, and OC vector is equal to C vector. So which is step 1. Listen, it is very simple. Let OA vector is equal to A vector, OB vector is equal to B vector, next OC vector is equal to C vector. That's all. Okay? Let OA vector equal to A vector, OB vector equal to B vector, OC vector is equal to C vector. Okay. Now I want to find AB vector and AC vector. Okay. Can you tell me what is AB vector? Very good. AB vector equal to second minus first. OB vector minus OA vector. That is B vector minus A vector. Okay. Next AC vector. AC vector equal to, yes, OC vector minus OA vector. That is C vector minus A vector. Which is very simple. So let us write a directly formula. Area of the triangle ABC is equal to of into modulus AB vector cross AC vector. Okay, let us write a directly formula. Area of the triangle. Listen. Area of the triangle. Area of the triangle ABC equal to, that's all. Area of the triangle ABC equal to of into modulus AB vector cross AC vector. That's all. So which is equal to of into modulus AB vector cross AC vector. Okay, which is equal to of into, here apply yourself. Okay, now can you tell me what is AB vector? Yes, second minus first. OB vector minus OA vector. So AB vector is equal to OB vector minus OA vector. What is middle relation? Yes, cross product, int, cross product of AC vector. AC vector equal to, good, second minus first, OC vector minus OA vector. OC vector minus OA vector. Modulus complete, that's all. So formula, AB vector is equal to OB vector minus OA vector cross AC vector equal to OC vector minus OA vector. Okay, now just a substitution. Okay, now int, what is OB vector? Yes, good. OB vector equal to B vector minus OA vector equal to, yes, A vector cross OC vector equal to, good, C vector minus OA vector equal to, yes, A vector. Complete the modulus. Okay, which is equal to of into modulus. Ah, good, very good. Here, this B vector and the cross product going to multiply inside the bracket. Okay, inside the bracket we get B vector cross C vector. B vector cross C vector. Okay, B vector cross C vector. Similarly, plus into minus, minus B vector cross A vector. So minus B vector cross A vector. Okay, similar idea. A vector and the cross going to multiply inside. A vector and this cross product going to multiply inside the bracket. We get, yes, minus into plus, minus A vector cross C vector. A vector cross C vector. Okay, next step yourself. Good, very good. Minus into minus, plus A vector cross A vector. So plus A vector cross A vector. Complete the modulus. Remember, say first one 2 times, second one 2 times. So how many times in the product? Yes, 2 2s are 4 times in the product. Count it. First term, second term, third term, fourth term. There are 4 terms are there. Okay. In which any further simplification? Very, very good. Here A vector cross A vector tends to 0 vector. 0 vector. Can you tell me what is the reason? Good. Cross product of itself vectors tends to 0 vector. A vector cross A vector equal to 0 vector. B vector cross B vector equal to 0 vector. X vector cross X vector equal to 0 vector. Likewise. I cap cross I cap tends to 0 vector. Likewise. Okay. So the last one tends to 0 vector. No need to write. Okay. There are 4 terms are there, in which last term tends to 0 vector, no need. And remaining how many terms are there? Yes, very good. 3 terms are there. Okay, 3 terms are there. But the required answer, we need all the positive terms. Listen, positive, positive, positive. Okay, so that is why here negative we want to make as positive. Okay, can you tell me what is minus B cross A equal to? Very good. So minus B cross A equal to plus A cross B. While interchanging in cross product 2 vectors, that we get one negative sign. So B cross A equal to, listen, B cross A equal to minus A cross B, already one minus, so minus into minus plus. Okay, similarly, A cross C equal to minus C cross A, already one minus, so minus into minus plus. So interchange these 2 vectors becomes plus, interchange these 2 vectors we get plus. And also I want to write in alphabetic order. Alphabetic order means while interchanging I get A to B. Okay. And the second term as it is, B to C is in the standard form. B to C is in the standard form. Let us write this first term as in second place. So this second term I want to write as first, because while interchanging we get A to B, right in first. And B to C as it is in center. And while interchanging we get C to A. Let us write in cyclic order. Now listen, which is equal to of into modulus, say B cross A equal to minus A cross B, minus into minus plus, right in first place. So that is A vector cross B vector. And it is A to B, okay. Now B to C as it is, right in second term, plus B vector cross C vector, plus. Okay, listen, A to B, B to C. Next I need C to A, yes. So A cross C equal to minus C cross A, minus into minus plus. So plus C vector cross A vector, complete the modulus. Listen, A to B, B to C, C to A. Okay. Now write its left hand side. What is left hand side? Area of the triangle. Okay. Area of the triangle. Area of the triangle. Area of the triangle ABC equal to, area of the triangle ABC equal to of into modulus A vector cross B vector plus B vector cross C vector plus C vector cross A vector. So in this question there are 2 parts. Listen, which is the first part, which is completed. So that the area of the triangle ABC is equal to of into modulus A cross B plus B cross C plus C cross A. So first part is completed. Now I want to find second part. I want to answer for second part. Okay. We know that if area of the triangle equal to 0, then the 3 points A, B, C are collinear. Conversely, if A, B, C are collinear, then area of the triangle ABC equal to 0. Okay. So if A, B, C are collinear, therefore area of the triangle ABC is equal to 0. Listen, now if A, B, C, if A, B, C are collinear, if A, B, C are collinear, then area of the triangle ABC equal to 0. Then area of the triangle. Then area of the triangle ABC equal to 0. That's all. If A, B, C are collinear, then area of the triangle ABC equal to 0. Okay. See, already area of the triangle ABC answer is we completed. Okay. Now, therefore, area of the triangle ABC equal to 0. Therefore, see area of the triangle ABC is equal to 0. Okay. Area of the triangle ABC equal to 0 means, what is its answer from the first part? Very good. That is, area of the triangle ABC is given by of into modulus A cross B plus B cross C plus C cross A. Okay, is equal to 0. Which is the first step answer. Okay. Now, this divided 2 goes to right, becomes, yes, multiply. Listen, 2 into 0, 0. So this 2, that is 1 by 2 no name. That means modulus A vector cross B vector plus B vector cross C vector plus C vector cross A vector is equal to 0. Okay? This divided 2 goes to right, becomes multiply. So 2 into 0 equal to 0. Okay. Now can you tell me, here modulus of a vector equal to 0 means, yes, modulus of a vector is equal to 0 means this inside vector is a 0 vector. Okay. Therefore, this inside vector is a 0 vector. That is A vector cross B vector plus B vector cross C vector plus C vector cross A vector equal to 0 vector. Because listen, for example, modulus x vector is equal to 0, therefore x vector is equal to 0 vector. So which is the formula? Modulus x vector equal to 0, then this inside vector is equal to a 0 vector. Okay, inside vector is a 0 vector, which is the formula. Okay, here modulus of a vector equal to 0, then this inside vector is equal to 0 vector. Okay, now which is the required condition for collinearity of the points A, B, C? So which is the required condition? Which is the required condition? Which is, listen, which is the required condition for collinearity of the points capital A, B, C? So which is the required condition for collinearity of the points collinearity of the points A, B, C. Okay, so hence the answer. Listen again, this question contains a two part. First one is, so that the area of the triangle ABC is equal to half into modulus A vector cross B vector plus B vector cross C vector plus C vector cross A vector. Okay, first part. Second part, deduce the condition that the 3 points are collinear. Okay, for that, we know that if A, B, C are collinear, then area of the triangle ABC equal to 0. Okay, that is area of the triangle ABC equal to 0, which is the first part answer is equal to 0. Then divided 2 goes to right, 2 into 0 is equal to 0. Now modulus of a vector equal to 0, which means this inside vector is a 0 vector. Therefore, which is the required condition for collinearity of the points A, B, C? So hence the answer.